Let's do another problem with a piecewise defined outcome function. And we're going to use Laplace transforms. They're the only way to fly when you have this kind of structure. Before you get started on taking the Laplace, though, you have a preliminary step, which is you need to write your function r of t using the u functions, using those unit step functions. And that is going to take a little bit of practice, a little bit of work, because as you start to manipulate them more, you get more used to it. So let's think about what this function does. So the outcome function here, this is my t-axis, and this is 1, that's 1. Then this outcome function here is just plain old regular t until I hit 1, and then it turns off. And then it is 0 from here on out. So I need to figure out how to write this using my unit step functions. So because the change is happening at 1, I know for sure that I'll want to use this beast. But remember that this beast is 0 until you hit 1. And then it turns on. And that is the opposite of what we want. So that means that in order to have my function be on from 0 to 1, so I want it on, and then to turn off, I need to subtract this off of 1. And my r of t will be t times the quantity 1 minus u of t minus 1. Because that's what will let it be on first and then be off. So now my differential equation looks like y double prime plus y equals t minus t times the unit step function there that changes at 1, and I have my initial conditions as before. And now you're ready to use the Laplace. So the first step is to Laplace everything. On the left-hand side, we're going to have to use these formulas that you've worked with a number of times now. I'm going to switch my notation and use a capital Y when I hit the Laplace of the derivative and the function. So my Laplace of y double prime will be s squared capital Y of s minus s y of 0 minus y prime of 0, and then that will be plus y of s, because that's what's happening here. And while we're at it, let's take advantage of the fact that these initial conditions make those first pieces drop out. So the left-hand side is going to Laplace to s squared y of s plus y of s. And that will equal the Laplace of the right-hand side. So Laplace of t is 1 over s. And then I need to subtract off the Laplace of this piece. So that is where you're going to need one of our t-shifting theorems. And it will either be the first or the third one that I have here in boxes, because we're doing L forward, so we're doing the Laplacing here. And I can see that when I look at my function, I have a plain old g of t times one of these unit step functions. So this very first form is the one that we want here. And my g of t is t, and my a is 1. So g of t plus 1 is t plus 1. And that means that on this side of town I have 1 over s from before minus e to the minus s, that takes care of this piece, and then I need to Laplace my g function but shift it over to t plus 1. And that involves just looking at your formulas That should be a 1 over s squared. And then t goes to 1 over s squared. 1 goes to 1 over s when you take your Laplace. So cleaning everything up now, you have s squared plus 1 times the Laplace of y equals 1 over s squared minus e to the minus s, 1 over s squared minus e to the minus s, 1 over s. So I just did a little distributing there. And then the next thing to do is solve for y. Laplace of y. So I'm going to have 1 over s squared times s squared plus 1 minus e to the minus s, 1 over s squared times s squared plus 1 minus e to the minus s, 1 over s squared plus 1. Okay, bloody-doody, bloody-doody, bloody-doody-doo. Your next stage is going to be to take your inverse Laplace and that's easy. That's just going to be our little y function that we were looking for. So now we need to figure out what's going to happen with each of these 3 pieces. These pieces both have this exponential factor in it. And so they will both rely on this transform formula because they are each of that form of e function times the Laplace of somebody. They all look like this. But what are we going to do with those? Each of those individual pieces looks a little bit ugly. So let's take a second and even just take a brand new sheet of paper and just go off to the side and figure out what the Laplace of each of those pieces on this right-hand side are. So I want the inverse Laplace of 1 over s squared plus 1. And the appropriate thing to say to yourself is, And then the next thing to do is to say to yourself, well, let's take a gander here at my Laplace table. And if you look, you'll look over here at formula number 31. And that looks workable. So formula 31 tells us that kt minus sine of kt has Laplace transform k cubed over s squared plus k squared. And I can see that I fit that form with k equal to 1. So I am very happy because that first piece is going to inverse Laplace to 1 times t minus sine of 1 times t, better known as t minus sine of t. So the first of the 3 pieces here is handled. So now let's move over to the second piece. Okay, so that one bears a whole lot of resemblance to what we just did. The only thing is we have that e to the minus s there. So the thing to remember is that when you are Laplacing or inverse Laplacing something that is of this form, that it is a unit step function and a shifted f function. So here my a is minus 1 and my f of s is 1 over s squared plus 1. And using what I knew up here, my little f of t is t minus sine of t. So f of t minus 1 will be t minus 1 minus sine of t minus 1. And I can put that together to get my inverse Laplace on this piece to be f of t minus 1 times unit step function of t minus 1, which will just be t minus 1 minus sine of t minus 1 whole thing times unit step function t minus 1. So we have handled the second piece. And then last but not least, we have this guy. So we'll end up using this same formula here, but instead of combining that with formula 31, look what happens when you look at formula 30. So if you have a Laplace transform over here that looks like k squared over s times s squared plus k squared, that will go back to 1 minus cosine kt. So that's form 30. And we get k equal to 1 again. But now we are going to put those two observations together here. So my A is, wait, did I say my A was 1? Up here, that's a lie. A is positive 1. A here is 1. Our f of s is 1 over s times s squared plus 1. So using formula 30, little f of t is 1 minus cosine of 1 times t. So f of t minus 1 is 1 minus cosine of t minus 1. So using this, our Laplace transform here will be unit step function t minus 1, which is results from this creature, and then f of t minus 1, where this is our f. So this will be t minus 1 times the whole thing, 1 minus cosine of t minus 1. And now we can just put all that back in to the problem that we were working on. So little y of t equals here's the first part. And then here was the second part. Let's stick that off to the side there. So that's and then the third part. And yeah, you could simplify that a little bit more, but it's fine. It's also fine the way it is. Yay!